So I was told to put the street cred slide up first, so I'll do that. Just a little background. So I'm Vance Loiselle. I'm not a founder of Sumo Logic. I've been there about 2.5 years. The way the company was started in early 2010, my two key founders came from a company called ArcSight, which back about 10 years ago and even today was a company that was taking a lot of log data and security events from enterprise customers and trying to figure out what your security posture is. ArcSight was bought by, I think, HP. Yes, that's correct. My background, I was a co-founder of a company called Blade Logic, which was a data center automation company. And I constantly was selling to customers, for about 8 years before we went public and got bought by BMC. Customers were always saying, hey, how do you get downtime down? How do you reduce the problems that I have in my data center? How do you automate everything in the data center? But we figured out that problem, but trying to actually figure out the problem, we realized that half the time people were looking at the logs to figure that out, and it was very manual and cumbersome. So basically, Sumo Logic was started in early 2010 to take all the log data, machine data, and make it very easy for people to troubleshoot mission-critical apps, understand how their customers are using those apps, and securing those apps. And that's really what we're doing. Just real background, you can see where some of us came from. We're about 150 people. We were backed out of the gate by Grail, and then we just added Sequoia recently, and Excel, and Sutter Hill, and some other companies as investors. From a company maturity standpoint, we've been growing rapidly. We have about 400 customers, as you can see, and they fit in those use cases, and I'll kind of talk through some of those. So, machine data. Right, I'll just build this out really quickly. So here's 4 examples of customers we've worked with. It used to be, even a few years ago, that everybody talked about unstructured data sitting on networks and servers and firewalls, right? And you'll take an example like IBM and their global services business. They have hundreds and hundreds of terabytes every day that they need to figure out how to harness, get information from, run mission-critical apps, make sure their SLAs are being achieved. You look at more modern companies, right? Take a Netflix, right? Netflix is spitting out anywhere from 10 to 20 or 30 terabytes a day, and it's a pretty new company, right? Just trying to understand, are their customers logging in successfully in Brazil on PlayStation 3? And all that stuff is sitting in logs, unstructured data somewhere. Then you take an even more recent company like RingCentral, right? A cloud-based phone company, and they have mobile apps to help you connect, and talk to people. Again, 10 terabytes a day. Now you look at a device sitting on an airplane. One airplane, 2 engines, is generating 40 terabytes of log data an hour, right? And you see the news that recently about the tragedy on the flights that went down over the Pacific. The way they knew where those flights were was because they were getting updates in log data, pings from the satellites to see where those flights were. And it's all just unstructured data being spit out on servers on these devices. And the recent study, within the next 2 years, the amount of unstructured data that will be generated is somewhere in the 20 million petabytes a year figure. Right? It's basically 1,000x what it was even 5 years ago. So somebody needs to figure out how to harness it, and that's really what we're trying to do. So, what is it all about? So this is log data. For those of you who in here is like a developer or coder type? Oh, wait, we got some. All right, so this is what log data looks like. If you have a green screen or you're a developer, it gets spit out. It's just a bunch of gobbledygook text that's readable. The only thing that's common about log data, and even this isn't always the case, is it usually has a timestamp. You usually know, okay, when was this thing, date, time generated. And the challenge with it is, I don't want to use all big data terms, but the first problem with log data is, 1 terabyte is roughly about 2 billion events. It's 2 billion unique records. So even a mid-sized enterprise every day is generating over 2 billion records they need to figure out. So when you hear Home Depot or Target getting hacked, the only way they can figure that out is by looking at the log data, figure out what are people doing. And you can imagine they have tens of terabytes, really hundreds of terabytes a day they need to figure out how to look at. And when it looks like that green stuff, how are you going to do it? Second challenge is it's highly variable, right? So we had a great presentation right out of the gate, talking about how do you dedupe data and figure out semi-structured and structured data. This is even more difficult because it's all unstructured. There are no schemas. There's no logical record shape to it. You just basically have to take text and figure out how to turn it into something, a schema after the fact, not knowing what the intent of the data was. And the third thing is it's coming really fast. The majority of this data, the value, is within 15 minutes of it being generated. So, early on when we started building the platform, we're like, oh, let's use Hadoop and HDFS. And, back then there was no real-time nature. It was all batch. The terms ETL and all that stuff, we don't even talk about. We have to figure out how to take that nerdy event that gets spit out, and within a couple of minutes, we have to make it something visual and valuable to a customer. So everything that you do with unstructured data has to be real-time almost, with a few exceptions. So what can it tell you? So this is just some simple, monitors or dashboards from our product, and that's what actually generated it, right? So somebody fed in some log data that's actually telling you, and this is an example of our distributed application. We run about a 2,000 node cluster right now in AWS. This is for the components we run. We take some logs and we figure out, okay, where are the problems in the various stacks of our application, right? Just from some nerdy text data. Next thing we can figure out is, hey, for this data, at the infrastructure level, tell me just simple things like where are my Apache 400 errors and my 500 errors and so on, right? Just based on the log data that's coming through. Third example, when you have information you need to find out from either your caching or your Akamai or your CDN, all that data is valuable. You think about all the Akamai data that's sitting out there. You can glean unbelievable things about what your users are doing and how it's performing just by looking at the data from your CDN. Then you apply that. The reality is that it's great that you need to troubleshoot your app. You really want to know how's your business doing. By the way, that's all in the data. People have been spending millions over the last 10 years on tools like Omniture when all that clickstream information is sitting in logs on your web servers, right? Here's an example of revenue, how fast it's coming in, all just based on log data. And then lastly, you talk about security, right? What's actually happening from a security standpoint and a security posture, PCI, all of that is in this unstructured data, if you can just visualize it very quickly. So, our view over time, and we talk about analyst firms, and I heard a great question earlier from one of the analysts in the room. Gartner covers this space, and they talk about IT operations analytics. I believe it's much broader than that, and quite frankly, I think people in this space do as well. If you look at where unstructured data is going over the next few years, it's going to focus on really these kind of 5 quadrants. And I look at basically business service analytics. How do I, as a business person, generate money and make my customers happy? And how do we, as developers, make sure that we can continue to do that for them in a secure, safe, real-time way? And so everything from how your app performs, how your operations team meets its SLAs, how you display your security posture and measure it, how you support your customer and understand what's happening, what are they saying on Twitter and Facebook, LinkedIn, and so on, and what the business needs to hit their business objectives, all of that is going to come from a mix of semi-structured data and largely unstructured data over the next decade. And we're very focused on trying to help people achieve that. So let's talk about how we approached this technology and the problems we tried to solve, and I'll just build this out. So really it comes down to 4 components. First, and you hear a lot about cloud, and it was great, the previous presentation about Mesosphere, about AWS. If you're a developer, AWS and SoftLayer and all these platforms are money, right? I mean, the ability to be, a couple of guys having an idea and going a Greylock to now having 400 customers in 4 years was not possible, even 10 years ago, without companies like AWS and SoftLayer and so on. And so when we built a platform, the first thing that we said is we have to do this in the cloud. And the reason we took that approach is fundamentally because this real-time data is very chatty, right? Even as a single set of 10 servers, you could get anywhere from 50 gigabytes a day to 200 gigabytes a day, depending how bad things are. If shit goes crazy, you're going to get 200 gigs. If things are great, it's 10 gigs a day. That's just the nature of this. So we said we have to put in an environment where we can just burst up and down as we need with our customers. The second thing that we needed to do is figure out how to pass on that cost savings to our customers, right? And so with this kind of data, one of the real challenges is it's kind of a sum of peaks, peaks of some problem, right? You have some users who are hammering the system at times, and you have others not using it at all. And why should somebody have to pay literally tens of thousands of dollars for compute to index and search this data when there's 20 other people who need to use it, but maybe later in the day? And so we basically built an elastic architecture that we can spread a multi-tenant way across those customers. And with, think about putting Oracle in the cloud 30 years ago. I mean, it would just fall over, right? I don't even know if it worked today, quite frankly, but it would definitely fall over 30 years ago. That's the challenge that we had to solve, and I'll kind of show you some of the metrics. The other two things that we focused on from day one is it has to be real time. So a lot of the stuff that we built on a lot of open source technologies, but we had to rewrite a lot of them to try to figure out how to make these kind of technologies real time, how we did caching, how we basically updated a real-time index, so as soon as an event hit, we could display it on a dashboard, things like that. The real value, besides all that stuff and what we do, is we basically have data scientists. About a third of our engineering team are data science folks who basically build algorithms to figure out what is common about this data across hundreds of customers, so we can basically tell the next customer what they need to know without having to put all kinds of information into it, right? It's constantly learning. So you think of Google 10 years ago, right? You go in and you do a search and you just look at some metadata. Today, it infers what you were looking for just based on learning from the algorithms. So let's talk about how it works. So basically what we do, I'm not going to get too technical here, but basically what we do is we take all those data sources. You have a very simple collector. And you can basically put that collector anywhere you want, on-premise, in the cloud, what have you. We probably have about 60,000 collectors under management today. It does three things. It compresses the data about 10 to 12x. It encrypts it. We create unique encryption keys every day for every customer. And then we basically have a caching mechanism, so you can deal with any network latency if by chance that happens. And we just basically feed that data in real time into this big, massive ingestion farm that we have. And we just are indexing data in real time and making it available to you to do three things. One, you can search it. You can do very simple search. Find me errors for the last 15 minutes. And that's pretty valuable. Or you can do complex queries where you can say, find me all the users running my application across the globe, time slice by minute, sort by data center, sort by office, right? And then you can have a whole heat map of what's going on. Simple to complex. One query may take 3 seconds. One could take 3 hours, depending on the complexity, and that's why we burst to make sure you have query performance. The second thing that we do is we provide a whole real-time visualization engine. I like to call it a ghetto Tableau. It's actually pretty slick, but it's a real-time Tableau, right? Data's feeding in, and you can slice and dice the data as it comes in to visualize what's going on based on some of those examples I just showed you. The real value is this detection engine, and I'll show you an example of that in a second. But basically, our capability is to baseline your data every couple of minutes and find anomalies in the data to tell you about unknown events that are occurring, and I'll explain that in a second. Just to give you some visibility on kind of how we've scaled the system. So we built it for 2 years. We basically launched it in the middle of 2012. The blue, I'm a couple months out of date here, but the blue outlines the amount of compressed data that we're receiving. So we're at about 15 terabytes of compressed data per day that comes into the system. But the more important thing is the usage. So that number says 500,000. We've added 300,000. We do over 800,000 queries a day in our platform. So any given day, we have basically over 4 petabytes of data that's scanned in the platform and over 15 trillion records that people are going through. So, our view is, of all the use cases, if you look at applications, security, business analytics, why as developers, when you could be focused on building your mission-critical app, why spend time doing this too? You can just plug this in, scale as you need it, and get all the insights that you need, and we figured out how to scale it massively for you without having to buy hardware and on-premise software and all that kind of stuff. So the real value on what we're doing over the next 5 years is to find the unknown. If you look at our view, the holy grail of IT and security, it's this concept of finding what you didn't know. Tell me the problem without me having to look for it. So I can just be done with it and move on to my next problem. And so what we've basically done is built this anomaly detection engine to expand this sphere of finding the unknowns, allowing us to profile the data and telling you unknown events in your data so you don't have to figure out what query to ask about security. So you don't have these breaches you constantly hear about in the press. And so here's, just to dig into it really quickly, here's how we do it. We take all this gobbledygook of log data that has patterns. We have algorithms that kind of figure out what are the similarities about the data. And then we basically take those and we mask the differences and create basically what we call signatures. So you're looking at terabytes of data, and then you'll say, 550,000 Apache error 40X, right? Here's a bunch of signatures that we identified. Then what we do is we take those signatures and we say, okay, here are the signatures that we have, and we allow you to apply relevance. And so there's scoring that we bring in. If other customers hit those signatures, we apply those scores, so we tell you how relevant those signatures are. They could be nerdy security signatures or more business-oriented signatures. And then what we do, all of these signatures follow patterns. Typically in any day, holiday period, there's always a flow and ebb in how signatures relate to each other. These Apache errors with these ACL permission changes, what have you. And so we find, tell me based on the baselines, when a signature change, when the relationship of signature changes, that's an unknown event, right? That's something that you didn't know to look for. And that's basically our anomaly detection engine. We take all of the things that people try to do around search and aggregation that you could try to build over the next 12 to 24 months. We do all that stuff, and then we create a heat map of unknown events, whether they be business events, security events, application events related to your data. So just to wrap up, just to give you some idea of where we're going. So we have one competitor out there. I'll name them. They're called Splunk. So if you're familiar with Splunk, we're taking them down, and we're taking them down hard, and they know it. And we basically, from day one, about 7, 8 years after them, said we're going to build it from the ground up with cloud. It's going to be massively scalable, and we're going to make it about machine learning. And we're already, causing them pain. So if you want to look at something in this realm, you definitely should take a look at us. And that's all I have to say about that. Okay?
Thank you. How do you really feel about Splunk?
I love them. Hey, honestly, to be perfectly frank, Splunk is a great product. They carved a market for us, but there's always time for disruption, and now is the time. Okay.
So if I understood this correctly, so everything is processed in the cloud?
Yes, correct.
Okay. And what's your sense of the state of readiness of the market? Is big data eventually all moving to the cloud?
I don't think it'll all. There'll always be some perception that some workloads should stay on premise. But if you look at where the industry is going, I mean, the majority of mission critical data that's out there today is in the cloud, and people don't realize it. I mean, Bloomberg, it's a massive cloud organization. I mean, all the data that's fed to all these financial services firms, Bloomberg's a big cloud, and they're providing it to a financial services firm. You look at Thomson Reuters, they're doing the same thing. You look at Dell SecureWorks, these banks are sending security data, log data to, managed security providers to analyze security breaches today. So I think cloud, even though the term hasn't been used, has been out there providing data all over the place. I think now it's just, the cloud as an infrastructure is becoming more prevalent. So I think you'll just see it explode. Akamai, one of the largest clouds in the world. The data's out there. I think it just makes sense with the, I've seen a palpable change in the last 12 months with, I think, the IPO of Workday and ServiceNow and others that, it's inevitable a large amount of this processing will go to the cloud, just so people who that's all they focus on, you'll provide their focus area.
Great. Questions? Over there.
Thanks. Great presentation.
Thank you.
So I was interested in the anomaly. Sorry. Yoni Malki from Worldwide Technology.
Great.
So I was interested in the anomaly detection engine that you have. Just curious how you handle false positives, because I know that, depending on the event, some false positives fine for some events, some it's very critical and you can't have it. So how does that get?
Yeah, great question about false positives. So I mean, if you look at this industry, in the last 10 years, been a lot of skepticism about machine learning and anomaly detection. If you look at companies that I'd come from before, they basically taken metrics data, monitoring data, and try to do some kind of anomaly detection. Well, our approach was we basically learned from our cousins at LinkedIn and Google and others that you have to have human interaction with the data. So as soon as we find an unknown event, we don't suppose that we know what it is. We provide you a blue box and we say, here's an unknown event. When you click on it and you say this is the relevance of it and here's a description of what it is, before you do that, we check to see if anybody else has seen an event like that, and we give you some human input based on that. And if it's one that we haven't seen, then you can score it, and it'll either you can say not relevant, or in the future, if it is, it'll find every event like that in time. So it's probably realistically out of the box 70% accurate right now. But as you apply relevance to your data in your organization, it learns over time. Yeah.
Good. One last one over there.
Hi, my name's Violet with IBM. Nice talk.
Thank you.
Out of curiosity, do you consider yourself a security solution, a big data solution, or is it a mix of both?
Good question. Depends how big the check is. No, in all seriousness, it's very interesting. I think it's one of the challenges, quite frankly, we've had as a business. for one reason or another, there's been very few companies that have crossed from, IT and data to security or done both at the same time. And really big companies, your company, does it pretty well. Our view, so today our business, 70% of our business comes from mission critical application buyers. Either a business owner or a DevOps person that has to make sure their mission critical app is running. And then 30% of our buyers come from the CISO, who basically say, I've got to have a security posture I'm confident in. What we find is there's kind of a blurring of that, where I've got a mission critical app, and man, if that is not secure, I'm screwed, right? And so we find security buyers funding the DevOps buyers. We find DevOps buyers pulling in security folks. So those are the two that we really focus on, when our sales folks try to dumb it down. Yeah.
Thanks. One last one, if you can run to my other guy.
Hi, my name is Matt Kroll. I work for MongoDB. You're co-founder from Blade Logic.
Yes,
just started
Mr.
with us.
David Echeri, congratulations.
Thank
Great
you.
hire.
We try. So, first of all, I wanted to thank you for being one of the only people ever on the stage to properly define big data about meaningful insights. So that was very relieving. But my question to you is, okay, so you guys have seemed to master this whole process around log analytics, management, and so forth. But why not go after more than just Splunk? About, say, take the algorithms you guys have built and go after Palantir in terms
Sure.
of, other, data mining and other more business-specific areas.
Yeah, no, great question. I mean, I think if you look at, there's a whole lot of low-hanging fruit out there that we could go after, like take an Omniture, for example, right? Not to call Adobe out right now, but there are a lot of places that we could go. I would say we've done a good job. We haven't mastered what we do yet. There's still a lot of stuff we can do with integrating structured data into our platform. But we like to win and own a hill and then go to the next one. So but definitely on the roadmap. Thank you.
Wonderful. That's
Great.
all the time we have. Thank you.
Appreciate it.